Hi, I'm Sam from the DigitMe2 team at UCLan, and this is a short video on overall equipment effectiveness.
This is the first of two videos where I will go through OEE, or Overall Equipment Effectiveness, quickly going through what it is, why you'd use it, and a few commercial applications. Part 2 deals with low cost applications, what we as the DigitMe2 team can do for you, and how you get started with machine monitoring. So your overall equipment effectiveness is a massively popular metric to just quickly see how efficient your factory is running. It takes into account the availability of a machine, the performance of a machine, and the quality of the output of the machine. These three values are all calculated as a percentage, and then you combine these three to get your final OEE figure. A standard figure might be 60%, 70%, but it really depends on your industry. There's plenty that are below 20% even, and then once you get to 80%, that tends to be, top of the line on top of everything. I'm going to guess if you're on this video, you're already quite interested in OEE, so I don't really need to sell the benefits of it to you. But I'm just going to quickly go through why you might want to use OEE, some of the benefits, and who else is using it. So why should we bother? It's quite a lot of work putting a system like this in. You'll find a lot of operators might have a bit of kickback against it, but it's definitely worth the benefits. You might have heard about Industry 4.0 with new smart factories, and maybe you're thinking about getting into that. And it is the first step is measuring your OEE. A core foundation of Industry 4.0 is knowing about everything that's going on in your factory, knowing where everything is, how efficient everything is, and OEE is the gold standard there. Or you might just be interested in identifying losses, finding when you can make improvements, and staying competitive. This is often called finding the hidden factory, so that's the factory that's within your factory that could be working, could be making products, but it isn't. It's lost to inefficiencies and things like that. And OEE is great at spotting those inefficiencies. Which brings me around to the return on investment. You might just want to know if your machines are worth the while. For a few examples of what companies have done after measuring OEE, I've dropped a few examples in the description. And with that said, let's get on to how you actually calculate it. Okay, so the first step is to calculate our scheduled working hours, which is quite simply the hours we're at work. If we're working 9 till 5, then 9 to 5 are our scheduled working hours, and we're just going to ignore the rest of the time. It's a scheduled loss, and it's not going to factor into the equation. If you wanted to include your scheduled losses, then that would not be the OEE, you'd be calculating the TEEP, or Total Effective Equipment Performance. This could be useful if things like overtime or unscheduled working are sort of messing your OEE figure up, but it'll give you a much lower figure, and a lot of people won't like that, so you don't see it being used quite as often as OEE. This allows us to get the availability of all the machines, which is essentially, is the machine running? Is it in uptime, producing parts, or is it in downtime, doing nothing? And downtime will include things like operator changes, material shortages, anything planned or unplanned, which is long enough for the operator to record. Some people like to leave out some of the planned stops and say, we've scheduled for this, so it doesn't count, it shouldn't go down as a stoppage. But I'm not a fan of that. You don't get a true picture once you start doing things like that. And if, for example, operator changes are giving you a big loss, well, that's something you'd want to see. So if you miss that, then you miss the opportunity of improving your efficiency there. And one last thing, don't worry about the short stoppages. If it's less than a minute, I'm not too bothered. It takes the operator too long to record things like that. And if there's an excessive amount of short stoppages, then we'll tend to start seeing that in the performance later on. So the next factor is performance, which is the machine running at full efficiency? This is calculated by comparing the outputs of the machine against a theoretical maximum output of the machine. So if on an ideal cycle time it was making 10 parts an hour and it's actually making 8 parts an hour, then that's an 80% efficiency. This is another area where it might be tempting to use a slightly lower figure, but if you use anything less than your theoretical maximum, you're hurting yourself in the long run. It will make your figures look better, but you could be missing out on efficiency. Not only that, but if you then happen to go over your stated theoretical maximum, you're going to get over 100%, and you don't want that in your numbers. And the final factor is quality. This just accounts for the product that we don't actually use, that we scrap, and doesn't go towards efficiency. We don't include rework in this calculation because that's eventually not scrapped, and we just calculate the downtime spent reworking the part. Just going to run through a quick example so you can see it in action. Take a machine, this could be any sort of CNC machine, a lathe or a press, whatever. Say it's meant to run from 8 until 6. That's your planned production time, so we've got 10 hours to work with that it should be running. But when you watch it, you find out it's only actually running for 8 hours. That 8 hours is availability, so 8 over 10 is 80%. You've got an availability of 80%. Now let's say the maximum output for this machine is 100 parts an hour. So over 8 hours you'd expect to get 800 parts, but that's if the machine was running flat out. When we don't actually see this, we only actually end up seeing 600 parts. We use the expected output and the actual output to calculate the performance, which is 600 over 800 or 75%. Say we scrapped 60 of the parts, we only ended up using 540 of them. We would use 540 over 600 or 90% as our quality figure. Now we've got values for quality, performance and availability. We multiply them all together to get 54%, which is our final OEE figure. As you can see from this, it's quite simple to measure your quality and it's quite simple to measure your performance because these are figures you're probably measuring anyway. You're going to be measuring your parts produced, you're going to be measuring your scrap. The thing you might not measure is your uptime. Now, there's quite a few ways you can measure your uptime, so we'll just go into a few of those right now. You can either record your uptime manually or automatically. If you were doing it manually, you'd probably want a tablet or some other electronic data entry. You can use a pen and paper if you really want, but I'd rather you didn't. You're just going to put extra errors into here. Nobody likes data entry, and you're delaying your data as well. If you've got it in a tablet or something like that, the data's available almost straight away. If you're writing it down, maybe the next day after somebody's typed it up, just don't do it. For the automated methods, you've got a few different options. So most machines will be monitoring their own condition. They'll have plenty of sensors telling you various factors. Depending on how new it is, depends on how much information you're going to get from it really, but at the minimum, you'll be able to find whether it's running or not. If you're lucky, your controller's going to be able to give you your uptime figure straight away without any messing. This often isn't the case though, and you'll end up with some dedicated hardware that's monitoring the signals from the machine and interpreting it into your uptime figure. You'll also want to record a reason next to the downtime so you can see why it's happening, why you stopped. And also your company might consider some type of downtime as scheduled downtime or something that you don't want to count towards availability, so it wouldn't actually negatively affect your OEE score. And finally, how are we going to do the calculation once we've got all the data? A common way is putting it all into Excel and having a spreadsheet calculate it. This is a valid way, it's quite a common way you see in a lot of companies. If you want to be serious about recording data, I would really suggest using a structured database, like for example SQL. This will give you much more flexibility in the future if you wanted to use your data for something else, and you'd use this with a program like Microsoft Access or PostgreSQL. You'd also need some supporting software to handle inputting the data and maybe outputting it elsewhere. So this is a bigger investment, but it will pay off in the future. The DigitMe2 team does have its own OEE software, which is open source, available on GitHub, and I'll go into this in the next video.